Inverse trigonometric functions. The quantities such as sine inverse x, cos inverse x, tan inverse x, etc. are known as the inverse trigonometric functions. So, inverse functions, we know this term inverse, isn't it? X inverse, like that we have studied. But inverse, that is sine inverse, is opposite to sine. Cos inverse is opposite, that is inverse of cos. Okay, so if sin theta equal to x, then theta equal to sine inverse of x. So இங்க இருக்கிற sin இங்க போகும்போது while going to the other side, it will become sine inverse of x. Theta is equal to sine inverse of x. The domains and ranges of trigonometric functions are given below. For sine inverse, its range is minus pi by 2 to pi by 2. Similarly, for tan inverse x also minus pi by 2 to pi by 2, but here it is closed interval, here it is open interval. So, closed interval means this value minus pi by 2 and pi by 2 also included, but here it is open interval, so minus pi by 2 and pi by 2 will not be included. For sine, it is minus pi by 2 by pi by 2. So, for cosecant also, it is minus pi by 2 by comma pi by 2, where y is not equal to 0, because reciprocal எடுக்கும்போது the denominator should not be equal to 0. Here, cos x, its range is 0 to pi. So, secant inverse x also, the range is 0 and pi. For cot inverse, okay, tan inverse is minus pi by 2 by comma pi by 2. For cot inverse, its range is 0 and pi. Properties of inverse trigonometric functions. Here we are going to learn few properties like formulae, so we have to learn it. Sine inverse of sine x is equal to x. As we know, inverse on the same function, when it is coming together, it will be identity. Okay. So, it will be rationalized. So, it is x. Similarly, cos inverse of cos x is equal to x. Cosecant inverse of cosecant x is equal to x. So, inverse and the term, if it is coming together, it will be nullified and it is x. Property 2. Sine inverse of 1 by x, that is equal to cosecant of x. Sine and cosecant are inverses, isn't it? 1 by sine x the cosecant. Similarly, cos inverse of 1 by x is equal to secant inverse of x. Similarly, for tan it is cot once again. Okay. So, trigonometric, inverse trigonometric functions for negative values, negative functions. So, sine inverse of minus x is equal to minus sine inverse of x. We know sine, tan, cot and cosecant are odd functions. Cos and secant alone even functions. So, for all the other odd functions, it is sine inverse of minus x is minus sine inverse. Tan inverse of minus x is minus tan inverse. Cot inverse of minus x is minus cot inverse. For cos, cos inverse of minus x is equal to pi minus cos inverse of x. Similarly, secant inverse of minus x is equal to pi minus secant inverse of x. So, sin inverse of x plus cos inverse of x is equal to pi by 2. Tan inverse of x plus cot inverse of x is equal to pi by 2. Secant inverse of x plus cosecant inverse of x is also pi by 2. Pi by 2 is 90 degree. Property 5. These two are very important formulae. We used to solve many problems using this. Tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy. Similarly, tan inverse x minus tan inverse y, that is equal to tan inverse of x minus y by 1 plus xy if xy is less than 1. So, if plus comes here, then in the numerator also plus. If minus comes here, in the numerator it is minus, but here the opposite sign. If plus comes here, here it is minus. Property 6. Sin inverse x plus sin inverse y is equal to sin inverse of x into square root of 1 minus y square plus y into square root of 1 minus x square. 23rd example. Find the principal value of sin inverse 1 by 2. Second one, tan inverse minus root 3. So, first sin inverse 1 by 2. I take sin inverse 1 by 2 as y. So, sin y, while sin going to the opposite side, it is sin y, the inverse, sin inverse will become sin. So, sin y is equal to 1 by 2. For which value of sin we have 1 by 2? It is 30 degree, right? So, sin 30 degree is pi by 6, that is 180 divided by 6, that is only 30. So, 30 can be written as pi by 6. So, sin y equal to 1 by 2. 1 by 2 is sin 30, that is sin pi by 6. So, sin y equal to sin pi by 6, that implies y is equal to pi by 6. So, the principal value of sin inverse 1 by 2 is pi by 6. The second one, let tan inverse, second one, tan inverse of minus root 3. So, tan inverse of minus root 3 is equal to y. So, while going to the other side, it is tan y. Tan inverse inga anga pogumbodhu tan y. Tan y equal to minus root 3. For which value of tan we have root 3? It is 60. So, pi by 3. So, tan of minus pi by 3. So, y is equal to minus pi by 3. So, the principal value of tan inverse minus root 3 is minus pi by 3. First question in exercise 4.4, find the principal value. First one is sin inverse of minus 1 by 2. Let's take sin inverse of minus 1 by 2 as x. So, x is equal to sin inverse of minus 1 by 2. That implies sin x inverse. Sin inverse while coming to this side, it will become sin. So, sin x is equal to minus 1 by 2. What is sin pi by 6? That is sin 30. 1 by 2 is sin 30, you know. Okay. 30 and sin 30, we write 30 as pi by 6 in radian measures. So, sin x is equal to minus sin pi by 6. Okay. So, sin x is equal to minus sin pi by x. So, x is equal to minus pi by x. Fourth one, secant inverse of minus 2. Let x is equal to secant inverse of minus root 2. So, secant while coming to this side, it will become secant x. So, secant x is equal to minus root 2. We can write secant as 1 by cos x. So, 1 by cos x is equal to minus root 2. 1 by cos x is equal to minus root 2 means cos x is equal to minus 1 by root 2. Okay. So, what is the principal value for cos x is equal to, x is equal to pi minus cos inverse of pi by 2. It is according to the formula, principal value formula. So, x is equal to pi minus cos inverse of 1 by root 2. For cos 45 only we have 1 by root 2, that is pi by 4. So, pi minus pi by 4, pi minus pi by 4. Okay, this pi minus 1 by root 2 for cosine, pi by 4 only 1 by root 2. So, pi minus pi by 4, that is equal to, if we take 4 as LCM, 4 pi minus pi divided by 4, that is equal to 3 pi by 4. So, secant inverse of minus root 2 and its principal value is 3 pi by 4. You can mention the range also. Second question. Prove that 2 tan inverse x is equal to sin inverse 2x divided by 1 plus x square. Sin inverse of 2x by 1 plus x square. So, tan inverse x. Let's take tan inverse x is equal to theta. Tan inverse x is equal to theta. So, x is equal to tan theta. Tan is moving to the opposite side. So, x is equal to tan theta. Now, let's take the right hand side. Sin inverse of 2x by 1 plus x square. But here we have tan theta as x. So, instead of this x, I am going to substitute tan theta. So, sin inverse of 2 tan theta divided by 1 plus tan square theta. Instead of x, we have to substitute tan theta. Okay. So, 2 tan theta divided by 1 plus tan square theta. But for sin 2 theta, we have this formula, this identity. Sin 2 theta equal to 2 tan theta divided by 1 plus tan square theta in multiple angles identities. Okay, so instead of this, I am writing sin 2 theta. Now, sin inverse of sin. Sin inverse of sin. So, sin and sin inverse will get cancelled and we have 2 theta. Okay, x into x inverse. What will happen? X into x inverse. So, x into 1 by x. Both will get cancelled. Similarly, sin inverse of sin 2 theta. So, sin inverse and sin will get cancelled. It is 2 theta. What's a theta? Theta is tan inverse of x. So, it is 2 tan inverse of x and that's our left hand side. Hence, we have proved the result. Third one, show that tan inverse of 1 by 2 plus tan inverse of 2 by 11 is equal to tan inverse of 3 by 4. Here we are going to use an important identity. In the previous part, the second part of the second problem also, we have to use this identity to prove that. Okay. So, tan inverse x plus tan inverse y is equal to tan inverse x plus y by 1 minus xy. Here we have on our left hand side tan inverse 1 by 2 plus tan inverse 2 by 11. In the place of x we have 1 by 2. In the place of y we have 2 by 11. That is equal to tan inverse of x plus y. That is 1 by 2 plus 2 by 11 divided by 1 minus xy. That is 1 minus 1 by 2 into 2 by 11. So, here 2 and 2 will get cancelled, isn't it? 1 by 2 plus 2 by 11. For 2 and 11 we can take LCM as 22. So, 22 means here I have to multiply the numerator and denominator by 11. So, in the numerator we have 11. Here in the numerator and denominator we have to multiply it with 2, isn't it? 22 is our LCM. So, 2 into 2 it is 4. 11 plus 4 divided by 22. 11 plus 4 it is 15 by 22. In the numerator we have 15 by 22. In the denominator 1 minus 1 by 11. 2 and 2 will get cancelled. So, 1 minus 1 by 11. Here we can take 11 as LCM. So, if we take 11, here 11 minus 1. Okay. So, 11 minus 1. So, in the denominator you have 10 by 11. In the numerator you have 15 by 22 while simplifying. Okay. So, tan inverse of 15 by 22 while dividing with the fraction we can multiply it with the reciprocal. So, 10 by 11 will become 11 by 10. Okay. So, 2 5s are 10, 3 5s are 15. 1 11 is 11. 2 11s are 22. So, tan inverse of 3 divided by 4 and that is our right hand side. That is what we have to prove. So, left hand side is equal to right hand side. Hence, we have proved the result. Fifth one, solve tan inverse x plus 1 plus tan inverse x minus 1 is equal to tan inverse 4 by 7. Here it's not show that or prove that. If it is given like that, then we'll take one side, that means either left hand side or right hand side, then we'll prove the other side. Okay, but here it is solve. Solve means what we have to do? We have to find the value of the variable, isn't it? We have to find the value of the variable. So tan inverse x plus 1 plus tan inverse x minus 1 equal to tan inverse 4 by 7. Here also we are going to use our identity. Tan inverse x plus tan inverse y is equal to tan inverse x plus y by 1 minus xy, and it is an important property. So tan inverse x plus 1 plus tan inverse x minus 1 is equal to, in the place of x we have x plus 1, in the place of y we have x minus 1. So tan inverse of x plus 1 plus x minus 1 divided by 1 minus x plus 1 into x minus 1. Okay, tan inverse x plus 1 plus x minus 1. So plus 1 and minus 1 will get cancelled, and in the numerator we have x plus x, that is 2x. In the denominator 1 minus, here x plus 1 into x minus 1, a plus b into a minus b, that is a square minus b square. Here x square minus 1. Okay, so that is equal to tan inverse of 4 by 7. We are bringing that also because we have to solve. So tan inverse 2x by 1 minus x square minus 1. So when multiplying the minus inside, it will become minus x square, but minus on minus it will become plus here, plus 1 I do. So 1 plus 1 it is 2, 2 minus x square. In the numerator we have 2x. Okay, so 2x divided by 2 minus x square, tan inverse of 2x divided by 2 minus x square is equal to tan inverse of 4 by 7. When we are taking the values alone without inverse, it is 2x by 2 minus x square is equal to 4 by 7. Now we can cross multiply. We have to solve it, right? So to make it as a quadratic equation, we can cross multiply. That is 14x. Here while multiplying, minus x square into 4, that is minus 4x square. 4 into 2, that is plus 8. Okay, so 4x square while coming to this side, while bringing the terms to this side, minus 4x square will become plus 4x square. So 4x square plus 14x. Here minus 8 is equal to 0. That implies we have to factorize. Now all are even terms. So I am dividing the equation by 2. I get 2x square plus 7x minus 4 is equal to 0. We can factorize now. 2 into minus 4, it is minus 8. So the factors are 8 and minus 1. While adding this 2, we will get 7. Okay, so now we can rewrite the equation. So 2x square plus 8x minus 1x minus 4 is equal to 0. That equation. I am rewriting that equation with the factors. So while taking common as 2x into x plus 4 minus 1 into x plus 4. So the factors are 2x minus 1 into x plus 4 is equal to 0. So 2x minus 1 is equal to 0 means x is equal to 1 by 2. X plus 4 is equal to 0 means x is equal to minus 4. So the values are 1 by 2 and minus 4. Sixth problem. Evaluate cos tan inverse 3 by 4. So we have to find cos tan inverse 3 by 4. First I take this expression as x. Let x is equal to tan inverse 3 by 4. That implies tan. Tan while going to this side, it will become tan x is equal to 3 by 4. Tan x is equal to 3 by 4. What is the formula of tan? That is opposite side by adjacent side. Okay, so 3 is opposite and 4 is adjacent side. So angle x will come here. Okay, now cos of tan inverse 3 by 4. that is equal to cos x, because we take this expression as x. So cos of tan inverse 3 by 4 is equal to cos x. So here it is 3 and it is 4. We have to find the hypotenuse. To find the cosine value, we need hypotenuse. So square root of 9 plus 16, that is 3 square plus 4 square, that is equal to 25. That is 5 square and it is equal to 5. So cos x is equal to adjacent by hypotenuse. Adjacent is 4 and hypotenuse is 5. So cos x is equal to 5 by 4. That is cos x equal to 4 by 5 means cos tan inverse 3 by 4. Instead of x, we can substitute tan inverse 3 by 4. So cos tan inverse 3 by 4 is equal to 4 by 5. And that's the value. Next, sine of half cos inverse 4 by 5. Sine 1 by 2 cos inverse 4 by 5. Let x is equal to, similarly here also we are taking this expression as x. So x is equal to 1 by 2 cos inverse of 4 by 5. So first I cross multiply 2, that is 2x is equal to cos inverse of 4 by 5. While coming to the opposite side, it is cos 2x is equal to 4 by 5. So cos 2x is equal to 4 by 5. We have to find the sine value. Cos x irundhuduna 4 by 5 vachu we can draw the right triangle and we can find. But here cos 2x. So cos 2x, we have to write the formula, multiple angle formula of cos 2a in terms of sin a. Okay. So cos 2a equal to 1 minus 2 sin square a. We have this formula. So instead of cos 2x, I write 1 minus 2 sin square x. So 1 minus 2 sin square x is equal to 4 by 5. That is 2 sin square x is equal to 1 minus 4 by 5. This term is coming here and this term is coming there. So 2 sin square x is equal to 1 minus 4 by 5. 1 minus 4 by 5, that is equal to 1 by 5. Okay, so sin square x is equal to this 2, while cross multiplying 2 into 5, that is 10. So sin square x is equal to 1 by 10. If so, sin x is equal to square root of 1 by 10. So sin x is equal to square root of plus or minus square root of 1 by 10. What is our x? It is 1 by 2 cos inverse 4 by 5. Isn't it? 1 by 2 cos inverse 4 by 5. So sine of 1 by 2 cos inverse 4 by 5. Instead of x, I have given this expression. So sine of 1 by 2 cos inverse 4 by 5 is equal to plus or minus square root of 1 by 10. Seventh question. Evaluate cos sine inverse 4 by 5 plus sine inverse 12 by 13. We have to find the value, isn't it, for this. So evaluate cos sine inverse 4 by 5 plus sine inverse 12 by 13. So cos of this expression we have to find the value. So cos of sum of two values. Yeah. So I can substitute, I can use cos a plus b formula. So cos a plus b equal to cos a cos b minus sin a sin b. So here a is sin inverse 4 by 5 and b is sin inverse 12 by 13. So cos a plus b formula da potirukom. So a is sin inverse 4 by 5 and b is sin inverse 12 by 13. So a is equal to sin inverse 4 by 5. A sin inverse 4 by 5 na sin a equal to 4 by 5. What is our formula? Sin opposite side by hypotenuse. Okay. So with this we can find the other value. Similarly, b is equal to sin inverse of 12 by 13. That is sin b equal to 12 by 13. So with this sin a, we can find the value of cos a. With this sin value, we can find the value of cos a. Because cos A plus B is equal to cos A cos B minus sin A sin B. Sin A sin B we have, but we need cos A and cos B to substitute in this formula. So, using these values, these two values, this A and B, I am finding cos A cos B also. Okay. So, only we are using this. So, cos A equal to 3 by 5, that is adjacent by hypotenuse. Here as well, the opposite side is 12 and hypotenuse is 13. We have to find the adjacent. Square root of 13 square minus 12 square. 13 square is 169 minus 12 square is 144. While subtracting you get 25, square root of 25, that is equal to 5. So, cos B equal to 5 by 13. Now, we can substitute these values. 4 values we have: sin A, sin B, cos A, cos B. So, we can substitute in our formula. So, cos A plus B equal to cos A cos B. What is our cos A? 3 by 5. Cos B 5 by 13 minus sin A sin B. What is our sin A? 4 by 5 into 12 by 13. Okay. So, 3 5s are 15 by 65 minus 4 12s are 48 by 65. Okay. So, while subtracting we get minus 33, smaller number minus greater number. So, minus 33 divided by 65, that is cos A plus B equal to minus 33 by 65. What is our A? Sin inverse of 4 by 5. What is our B? Sin inverse of 12 by 13. So, cos of sin inverse of 4 by 5 and sin inverse of 12 by 13 is equal to minus 33 divided by 65, and we got our answer. 8th problem. Prove that tan inverse m by n minus tan inverse m minus n by m plus n equal to pi by 4. We have come again to the same old important tan inverse formula. Okay. So, left hand side here prove that. So, we have to take one side and we have to prove it is equal to the other side of the expression. So, first let us take LHS, tan inverse m by n minus tan inverse m minus n by m plus n. The same formula, tan inverse x minus, but we have in the previous problem we have used the plus sign. Now, it is minus tan inverse y, that is equal to x minus y. Inga minus irundha, inga minus numerator la. Inga plus irundha, numerator la plus, adukku opposite sign in the denominator. Okay, x minus y by 1 plus xy. So, tan inverse m by n minus m minus n by m plus n divided by 1 plus m by n into m minus n by m plus n. Okay, multiplication here. So, tan inverse of, in the numerator we can take n into m plus n as LCM. So, n into m plus n. So, here m into m plus n minus n into m plus n divided by here m into m minus n by n into m plus n. So, 1 plus m into m minus n by n into m plus n. So, tan inverse of m into m, it is m square plus mn minus nm, minus and minus it is plus, so plus n square divided by n into m plus n. Here in the denominator we can take n into m plus n as LCM, that is nm plus n square. Illaya? While multiplying it is nm plus n square. So, while taking this as LCM, here it is nm plus n square plus m into m, it is m square minus mn. So, we can cancel the like terms, mn minus nm cancel. Here as well nm minus mn cancel. Here as well in the denominator n into m plus 1 also n into m plus n. So, the denominator also will get cancelled. So, tan inverse of m square plus n square divided by m square plus n square, the leftover terms. So, m plus n square will get cancelled, that is tan inverse of 1. What is tan inverse of 1? Tan oda endha value ku 1 irukum? It is pi by 4. that is 40. Okay, 45. So, 45, that is our pi by 4. We have to prove that only. Okay, so pi by 4, that is our RHS. Hence, we have proved the result. Show that sine inverse minus 3 by 5 minus sine inverse minus 8 by 17 is equal to cos inverse 84 by 85. So, sine inverse this and minus sine inverse this is equal to cos inverse 84 by 85 nu show pannum. Let us take the left hand side. Sine inverse minus 3 by 4 minus sine inverse minus 8 by 17. As we know, sine is a odd function. It is an odd function. So, minus irundha adu irukum. So, my sine inverse minus 3 by 5, I write it as minus sine inverse 3 by 5. As well here, minus veliya varumbodhu minus into minus it will be plus. So, plus sine inverse 8 by 7. So, this is a negative term and it is a positive term. So, I am interchanging it. Sine inverse 8 by 17 minus sine inverse 3 by 5 is that is her equation 1. So, I take this as A and this as B. So, A is equal to sine inverse 8 by 17. Sine A equal to 8 by 17. Sine anga pogumbodhu sine A 8 by 17. As we know, if we have these two values, we can find the other ratios, isn't it? So, it is 8 by 17. So, the opposite by hypotenuse is 8 by 17. Now, we can find the adjacent, that is 17 square minus 8 square, square root of 17 square minus 8 square. That is our 15. Okay, you can find 17 square minus 8 square putting na 15 kadikum. Square root. Okay. So, now B is equal to sine inverse of 3 by 5. So, sine B equal to 3 by 5. Sine B 3 by 5 means opposite is 3 and hypotenuse is 5. We can find the adjacent and it is 4. Okay. So, this is our A and this is our B, A minus B. Okay. Cos A minus B. Now, I am using cos A minus B formula. Cos A minus B is equal to, because here this as A, we take this as A and B and we have to prove that it is cos inverse of 84 by 85. This is subtraction, two terms. So, cos inverse while coming to this side, cos agum. So, cos A minus B, if we use this formula, it will be easy for us to find the value. Okay. So, only cos A minus B formula, minus irukkiradnala minus, cos A minus B. We have used the same method in another problem also, isn't it? So, cos A, cos B plus sin A, sin B. We have our cos A values, cos B values, sin A and sin B. So, let us substitute this. So, 15 by 17 into 4 by 5 plus 8 by 17 into 3 by 5. While multiplying this, you get 60 by 85 plus 24 by 85. While adding this, the numerator will become 84 divided by 85. So, A minus B is equal to cos inverse of 84 by 85. Cos, while going to the opposite side, it is cos inverse. So, A minus B is equal to cos inverse of 84 by 85. What is our A minus B? Sin inverse 8 by 17 as our A and sin inverse 3 by 5. So, sin inverse 8 by 17 minus sin inverse 3 by 5 is equal to cos inverse of 84 by 85. And we have reduced this expression which is given on the question as this expression. So, instead of this, I can substitute this. So, sin inverse 8 by 17 as sin inverse minus 3 by 5 minus sin inverse minus 8 by 17, and that is our cos inverse of 84 by 85. Hence, we have proved the result. Once again, so sin inverse minus 3 by 5 minus sin inverse minus 8 by 17 is equal to cos inverse of 84 by 85. We have to prove. So, first we are taking the minus outside. So, this term will become sin minus sin inverse 3 by 5, and here minus and minus will get plus. So plus sine inverse of 8 by 17. In the next step, we are interchanging this. Plus term varra madri. Next minus term varra madri interchange pandrom. I take this as A and this as B. So sin A values, sin B values we have now, and let's find cos A values and cos B values. So as we have cos inverse here in the question, I take cos A minus B and its formula, and I am substituting the values. So cos A minus B is equal to 84 by 85. That is A minus B is equal to cos in the pakkam pogudhu, cos inverse of 84 by 85. A minus B, that is sin inverse 8 by 17 minus sin inverse 3 by 5. So that is equal to the given expression, and the given expression, instead of this we can substitute the given expression, and hence we have proved the result. 10th one, express in the simplest form tan inverse of cos x by 1 minus sin x is equal is. Okay, we have to express this in very simplest form, and x ranges over minus pi by 2 to 3 pi by 2. Now let's take the term, the expression which is in the brackets, that is cos x by 1 minus sin x. Okay, so if cos 1 sin, these three terms coming together, then we can write the formulae for this. Okay, so that we can simplify it very easily. So cos x, we have three formulae, cos 2a formulae, 1 for 1 and sin 2a. Cos 2a is equal to cos square a minus sin square a. Cos 2a irundhuduna cos square a minus sin square a, but here we have x term, cos x only. So we can divide it by 2, cos 2a divided by 2, this divided by 2 and this divided by 2. So cos x is equal to cos square x by 2 minus sin square x by 2. So cos sin vachi eludhiyachu. Okay, now we know cos square x plus sin square x is equal to 1, isn't it? So we can write 1 also in terms of cos and sin. Numerator cos and sin eludhiyachu, here cos and sin vachi eludhiyachu. For sin x, we have another one formula, sin 2a equal to 2 sin a cos a. Similarly here divided by 2, so here divided by 2 and here as well divided by 2. Angles ku mattum. So sin 2a divided by 2 means that is a, 2 and 2 will get cancelled, it is sin a. Sin a equal to 2 sin a by 2 cos a by 2. These are all half angles formula. These two are half angles formula, but it is not in our portion now. Okay, so sin 2a, that a is equal to 2 sin a by 2 cos a by 2. So instead of this sin x, I write 2 sin x by 2 cos x by 2. So cos x by 2 vachi eludhiyachu. Now in the numerator it is a square minus b square. So I write it as a plus b into a minus b. That is cos x by 2 plus sin x by 2 into cos x by 2 minus sin x by 2. A square minus b square, a plus b, a minus b eludhiyachu. Here in the denominator, a square plus b square minus 2ab. It is in that formula. In the numerator, it is a square minus b square form. Here, it is a square plus b square minus 2ab. So, I can write it as a minus b the whole square. That is cos x by 2. What is our a? Cos x by 2. What is our b? Sin x by 2. Cos x by 2 minus sin x by 2 the whole square. Okay. So, one term cos x by 2 minus sin x by 2 will get cancelled. Cos x by 2 plus sin x by 2 by cos x by 2 minus sin x by 2. Now, I divide all the terms by cos x by 2. Dividing all terms by cos x by 2. Because tan inverse kondu varanum nama. Okay. So, cos x by 2 by cos x by 2. Sin x by 2 by cos x by 2. Cos x by 2 by cos x by 2. Minus sin x by 2 by cos x by 2. So, here it will have get cancelled. So, 1. Sin by cos is tan. So 1 plus tan x by 2. Similarly, in the denominator, cos will get cancelled, that is 1. Sin x by 2 by cos x by 2, it is tan x by 2. Okay. So, what is our left hand side? Cos x by 1 minus sin x தான் இந்த அளவுக்கு கொண்டு வந்திருக்கோம். Okay. So, cos x by 1 minus sin x. Here we have 1. So, ஒன்று போல கொண்டு வரதுக்காக we can write this 1 also in terms of tan. Tan ஓட எந்த வேல்யூக்கும் 1 கிடைக்கும்? Tan 45. Tan 45 is equal to 1. That is tan pi by 4. So, I write 1 as tan pi by 4 plus tan x by 2. In the denominator also 1 minus, in the 1 விட்டுடுறேன். Okay, 1 minus 1 into tan x by 2. இல்லையா? 1 into tan x by 2. So, I write this 1 as tan pi by 4 because I want to bring this expression in this formula. Tan a plus b. Tan a plus b is equal to tan a plus tan b divided by 1 minus tan a into tan b. அப்படி இருந்ததுனா தான் இப்படி எழுத முடியும். For that, I am multiplying this by tan pi by 4. So, tan a plus tan b divided by 1 minus tan a tan b. What is our tan a? It is pi a is pi by 4 and b is x by 2. So, tan of pi by 4 plus x by 2. Okay. So, cos x by 1 minus sin x is equal to tan of pi by 4 plus x by 2. Okay. So, when tan is going to this side, it will become tan inverse of cos x by 1 minus sin x. Tan மட்டும் இந்த பக்கம் வருது. Okay. So, that is equal to pi by 4 plus x by 2. அதுதான் இங்கே கொடுத்துருக்கு. ரெண்டு பக்கமும் tan inverse எடுத்திருக்கோம். So, tan inverse and tan will get cancelled. It is pi by 4 by plus x by 2. So, tan inverse of cos x by 1 minus sin x is equal to pi by 4 by plus x by 2. This is the simplest form. We have to write the expression in simplest form. Isn't it? So, cos 1 sin வந்ததுனால we are using this 3 formulae to write this expression in terms of cos and sin alone. So, இதுக்கு ஒரு formula 1 can be written as sin cos square x by 2 plus sin square x by 2 minus sin x குரிய another formula. So, a square minus b square, using that I expand the numerator and a square plus b square minus 2ab. So, I write it as a minus b the whole square. So, like terms will get cancelled and I am dividing each term by cos x by 2 and I write it in terms of tan. 1 tan pi by 4 ன்றதுனால I will exchange 1 as tan pi by 4 plus tan x by 2. 1 minus tan pi by 4 into tan x by 2. So, it is in the form tan a plus b. So, I write it as tan pi by 4 plus x by 2. With this, if tan goes to this side, this will become tan inverse cos x by 1 minus sin x. That is in the expression in our question. So, tan inverse cos x by 1 minus sin x is equal to pi by 4 plus x by 2. That's the simplest form.